Okay, this particular problem reads, listed below are the annual data for various years. The data are weights, metric tons, of imported lemons and car crash fatality rates per 100,000 population. Construct a scatter plot, find the value of the linear correlation coefficient R, find the p-value using alpha equals 0.05. Is there sufficient evidence to conclude that there is a linear correlation between lemon imports and crash fatality rates? Do the data suggest that imported lemons cause car fatalities? Okay, so a little instructor tip comes up, use StatCrunch. It'll give you all the items asked for here. So you can almost always use StatCrunch on these and it'd be better off. You do not want to do these by hand. So if you click on that question help up here and look at the view and example, let's just do it. So when I click through this, look at the crazy stuff that they're wanting you to run. By saying you probably can't even see that. Okay, so you do not want to be crunching out R value, the R correlation coefficient, by hand. You don't want to even crunch out the test statistic by hand. So let me show you again how to do this on StatCrunch. So again, we're gonna open this up in StatCrunch. We only have a handful of values here, so you can use the TI, but I'm really going to encourage you to use StatCrunch on this. Okay, so we're going to go to Stat, Regression, Simple Linear. Now what you probably should do first is go to Graph, Scatterplot. Let's go ahead and do that. And it even helps us out. Lemon exports are X, Y variables crash fatalities. And we will just take all the defaults and press Compute. And there is our plot. And that looks like it, follows a linear pattern, roughly. These are never going to be perfect, right? Roughly linear. Because if it's not linear, we can't use linear regression. So, close out of that. Go to Stat, Regression, Simple Linear. Going to select our X variable, lemon imports, select the Y variable, crash fatality rate. Okay, we're going to perform a hypothesis test on the slope. And if you want anything else, let me see if I can pull this up a little bit. So just notice there are other graphs that you can tack onto this, histogram of residuals, QQ plot of residuals, and so on. And you can also save some of these pages too. So we're not going to do that. We're just going to go ahead and click Compute. It'll automatically give us a scatter plot, I believe. Let's see. Yeah. So again, I can click through next one, and there's our scatter plot. And it's got the line of best fit right through there. So let's scroll on back here. So here's our line. Our equation, y equals 16.54 minus 0.003066 times lemon imports. There's our correlation coefficient, negative 9.61. There's our coefficient determination, r squared, 0.92. Just kind of look down here. We're looking at the slope. There's our slope. Notice the slope here, same one that's up here. Notice our test statistic is negative 6.01, p-value 0.0092, and so on. We're not going to look down here quite yet, so maybe in the next lesson. Okay, let's go ahead and state our null and alternative hypothesis. We have rho equals 0. We know it has to be equal 0, so we know it can't be C. And it doesn't really give us a direction here, right? So it just says, is there evidence to conclude that there's a linear correlation between those two? So we're going to select A. Okay, recall that scatter plot. Looks like it was A. Okay, the linear correlation coefficient. Pull this up for you. Okay. That is R, and it says around to 3 places, so let's pull this back in. Okay, and R is this value right here. So negative 0.961. Okay, what's the test statistic? So we are not going to be looking at the intercept in here most likely, so we're looking down here at the slope. Negative, let's see how many places to round to 3 places. So negative 6.010. Okay, and the p-value, again, our p-value, we're looking at the slope, 0.0092. So it's 3 places, so 0.009. I think it would count it wrong if you put 0.92. So, okay, so the p-value is low, right? So it's definitely less than 0.05. So less than 0.05. So there is enough evidence to support the claim that there is a linear correlation between the limit imports and crash fatality rates. But you got to be careful here. So is there a causal relationship here? No, right? We cannot claim cause and effect. We can't, if I import more limbs, is that going to actually cause the crash rate to go up? There's most likely some sort of confounding variable here. So the results do not suggest any cause-effect relationship. No matter how strong, we cannot do a cause and effect. So on the TI-84, let's see how to do that. We're going to go to Stat, Edit, and let's go ahead and clear out these lists. Now let me show you, if you've got a bunch of lists in here, how you can clear them out all in one swoop. Let's go to Stat. You see this clear list, number 4. I can just press number 4. And then I have to put L1, comma, L2, comma, L3. Okay, now when I go back in there, all those lists should be cleared out. Good. And let's go ahead and type these numbers in. We'll put the limit imports into L1 and the crash fatality rates into L2. Okay, so I have the list put in, and you can actually get it labeled if you want to. I'm just going to leave it as L1 and L2. Let's make a scatter plot. So you're going to go to second, y equals, turn on your plot. So turn it on, and this first type here is a scatter plot. And to graph it, we're going to press zoom 9. So zoom and number 9, zoom stat. And that looks pretty good. Looks very close to what I did when I did this in StatCrunch. And I can press trace and trace these out. So 229, 15.9. Well, that point doesn't look right, does it? Scroll over. This one says 16.6. So that doesn't sound right. Let's check the other ones. 15.5, 15.2. 14.8. Yeah, so I've got an error here. Stat, edit. So this should say 15.6. You guys probably caught that when you were watching me do it. Luckily, I caught it too. Try this again. Zoom 9. There we go. That looks more like, I think, the one I did in StatCrunch. Okay, now let's go ahead and run a regression on this. So I'm going to go Stat, Calc. We're going to do linear regression. And you can either do linear regression number 4 or linear regression number 8, depending upon what form you want. This is ax plus b. This is a plus bx. So we'll just do number 4. We have list 1, L1, L2, frequency list. And we just want to delete that frequency list out. Okay, we have L1, L2. If you want to store your regression equation, you can. So like I can press vars. It's a y variable. It's going to be a function, and we'll stick it into y1. Completely optional. And then press calculate. So here's our equation. Negative 0.00307x plus 16.54. Exactly the same one we had before. These were just switched around. A had b plus ax, or a plus bx, however you want to think about it. Here we're looking for linear correlation coefficient, 0.961, exactly the same thing. It didn't ask for it, but the coefficient of determination, r squared, is 0.923. Exactly the same thing within StatCrunch. If you don't see r squared in r, you have to turn the diagnostic on. So you go to second catalog, maybe an easier way to do this, and I'm going to go, you can scroll down till you get to D, or you can go ahead and press alpha D, alpha this x negative 1, and it gets you a little bit quicker. And go to diagnostic on, and just press enter. and then press enter, and then go back and run that regression. Stat calc number 4, and calculate. Okay. So how do we run the test on this? So we're going to go to stat, test, and it's a linear regression t-test. I don't think we're going to do linear regression t-interval here, but if you needed to do that, it's right there. So x-list is L1, y-list L2, frequency can keep it at 1, but now we're going to change our hypothesis. Remember, this is not equal to. If you want to pop the regression equation in, you can. We've already done that in y1. Again, you can go vars, y-vars function, and pop it back into y1, and then calculate. We get the same thing we got before, right? So we have a t-statistic at negative 6.01, p-value 0.009, and so on. And it actually gives us the equation here as well. So we didn't really have to do that linear regression only. We could have gone straight to here and not have to do two different ones. We often don't run a test on the slope or the y-intercept, so you can just go there. Either one is fine.